All right. Hey, everybody. I know that you have a problem set this weekend, so I'm going to try to make this video pretty quick. I think it should help you. In the last few sections, we've really spent time looking at the angle relationships with circles. Now, I know what you're thinking. There's a whole bunch of angle relationships, different names. Do I need to know the names of these different angles? Not really. It'd be nice if you knew what a central angle was. It would be nice if you knew what an inscribed angle was, but did I really memorize this in high school or even beyond until I became a geometry teacher? The other angles, tangent chord angles, two chords angles, tangent secant angles. No, I didn't memorize that. And it's not really worth your time, I think, really focusing on that. But what's worth your time, though, focusing on is, well, how do I solve problems using these different angle relationships that we've kind of identified and some of which we've proven them? And that's what I'm going to help you out with today. That's what the purpose is of this PDF document right here. Now, if you have a printer, it'd be great if you printed this out because then you can mark it up. You can color code it. You can really point things out there. And really the goal of this is just graphically make sure you know what the heck we've been talking about the past few days and ultimately get this sort of simplified down to you into just 4 formulas that you're going to have to pull up as you answer problems as we wrap up chapter 7 over the next couple weeks. So anyways, just to remind you what our goal was going into chapter 7, circles is, we're looking at this different world in geometry. You should know a little bit about it, even though this year is really weird with distance learning. The essential question was, well, can I identify any interesting relationships between circles, angles, and lines? Circles, angles, and lines. So we looked at lines earlier. We looked at tangent lines. We looked at chords, right? Looked at chords relating to their arcs and whatnot here. But we're not focusing on tangent lines, just what the line relationship does. And perpendicularness, that word won't come up today. Perpendicularness isn't even a word. But anyways, we're not really thinking about lines today. We're thinking about angles and circles. That's what the focus is of this graphic organizer. And if you sit down with me for the next 15 minutes or so, I think maybe you'd have another tool to really sit down. You're sitting down here in section 7.6 this weekend, seeing a problem, you're going to realize, hey, I think I can apply this formula to this. And some of this is logical. Some of this will be common sense by the end. Be like, oh, I think I can remember that. So try to listen to little tips that I have for how people kind of organize this in their head. All right, let's go through it. We got to go through 4. There's really just 4. So I know there's a whole bunch of angle relationships. And again, you don't really need to know those words like two chords angles, two secant angles, tangent secant. It's not really worth your time to know all the different types of angles because I think there's, 6 or 7 at this point. There's really just 4 things you need to consider when you sit down to do problems like these, right? You got problems like this, right? Look at this, all this stuff. We got all these angles. This is this gobbledygook here, right? As you might say, oh, this is just a mess. You want to see this and realize, and the thing to look forward to in problems like this and to ask yourself is this is the big moment. Where is the vertex? That's it. Where is the vertex here? Where's the vertex there? Where's the vertex here? Where's the freaking vertex here? Right? Vertex here. That vertex is on the circle itself, okay? Anyways, vertex is inside the circle. Vertex is outside the circle. Vertex is inside the circle. Vertex is outside the circle. Vertex is outside the circle in this theorem right here. So that's all you got to ask yourself when you sit down to do problems like this. Then you're going to pick a formula. That's it, right? And everything's open note this year. Hopefully the formula makes sense. That in this one, we got to subtract. And this one here, if it's inside, we got to add before we divide by 2. Anyways, let's just go through it with you so you have this all in one place in the organizer here. Just to remind you guys, if you sit down and do a problem and it's asking you this, well, I got this angle right here, ABC, okay? Measure of angle ABC. Here, if my vertex of the angle is at, well, what's significant about the vertex of this angle? That's the center of the circle. This is circle A right here. It's the freaking circle right there. So if my vertex of the angle is at the center of the circle, what can I say? What's the relationship? Well, the central angle, remember, defines the arc measurement. So this is where it all came from. We just happen to have proven things that follow from this about where other angles are located. And that's very neat, I think, here. So very, very cool, okay? So here, right? They just equal each other. I don't have to do anything. I don't have to multiply by anything. This here, right? Whatever this, that's not congruent, okay? But if this here, x degrees, this is going to be x degrees right here, okay? So I'm going to highlight this red here because we're talking about the arc. I'm going to be doing that a decent amount today to really highlight our intercepted arcs. So that tells us all about the angles or vice versa. Central angle here, going to have the same measurement here. Okay, measure of angle ABC equals measure of arc BC. And that is when we are at the center of the circle. Okay, so that's what I'm telling you today. That's what the whole point of this graphic organizer is to be like, well, where the vertex is going to be. Okay, you might want to draw this into your graphic organizer to really emphasize my vertex is at the center of the circle, so I know I use this formula. Okay, if I center, I use this formula. My central angle is the same measurement as its intercepted arc. All right, so written down here is just more things that I hopefully hammer through with you guys when I'm on, oh, vertex inside the circle, vertex outside the circle, vertex inside, vertex outside, vertex inside, vertex outside, vertex outside, vertex outside, vertex, where's the vertex? It's on, vertex on the circle, okay? So where the vertex is, vertex on the circle. Oh, this was a problem. I'm gonna give this problem from Friday classwork. This is a good problem. It's too good of a problem to skip over. It won't be on your homework. But anyways, the key to understanding the relationship between an angle measure and its arc measure is where the vertex of the angle is. That's what you want to look for in a problem like this. Okay, so I know it's overwhelming with the language. I want to simplify for you too. That's kind of the role of teachers, is get the information out there and then help you get organized around it. That's what I'm trying to do today. So if we know where the vertex is, we know it's that angle's relationship with its intercepted arc. So before choosing a formula to use, and we will come up with the formulas for all four situations here, ask yourself this question: is the vertex of the angle at the center of the circle? Is it on the circle? Is it outside of the circle? Now, there are three different types of angles that came up in the last lesson where the vertex was outside the circle, but they all followed the same formula, okay? So and the unifying thing with those three different type of angle types is that the vertex outside the circle. So that's what you should look for. And then finally is the angle inside the circle, okay? Is it inside the circle? Those are the only four things you should ask yourself, and then, hey, I think you can solve problems. If the vertex is on the circle, okay, so let's do it. On the circle here, we got these two situations already written down. If it's on the circle, remember, inside, inscribed. Inside, inscribed, except for one key point, except for the vertex, okay? So remember, an inscribed angle has, for instance, it's basically made up of, both sides contain a chord of the inscribed angle. So sure, the angle goes on forever, but let's just show those chords. So this would be an inscribed angle here, okay? Inscribed inside of the circle. Except for the vertex, okay, vertex here. So my vertex is right on the circle here, okay? We are on the circle, vertex on the circle. So that means that I have my intercepted arc right here. Let's call this x degrees, and that looks like, well, I don't know, a little less than 180, right? And that makes sense because this is less than 90 here, okay? Because simply going to be 1/2 x degrees there for an inscribed angle. Here, and then remember, what's the other thing that follows? What's the other type of angle that follows the whole 1/2 its intercepted arc thing? That was a tangent chord angle. And a tangent chord angle, let's look at what that has in common with an inscribed angle. Well, it has a chord. Let's maybe draw a chord in here. Okay, let's draw a chord right. Let me draw a different chord. I'll draw a chord right there. But it also has a tangent. As well. So I could draw the tangent, like it's got to be tangent to the actual freaking circle. If I'm here, then that's going to be not right because that's not a tangent here. I actually need to be a tangent here. So it kind of looks like this, and then there's my intercepted arc. I might do a bigger intercepted arc here. So tangent on this side is what I'm kind of thinking of here. So I got a tangent, eyeball it. Yep, that would just maybe kiss off the circle and go that way. So here's my angle right here. But the key thing is that my vertex is on the circle, okay, on the circle. And then I got this intercepted arc, which looks pretty freaking huge, doesn't it? Doesn't it look big? It looks like, whoa, it's like maybe 320 degrees or something like that, 320 degrees. And that angle will be, well, it can't be 320 degrees. It's got to be like 160 degrees. It's going to be half its intercepted arc. So if this is x degrees here, this is 1/2 x degrees. So print it out. Hopefully you label it on out. And then you have this visual thing. When I'm doing a problem, I can look at my little graphic organizer, and it's going to help me figure out what I got to do. Okay, so similar to this, let's write the formula down right here. Well, I got here B. Let's maybe mark it. We got A right there, so I'll do B, C, D right here. Maybe I'll do B, and then here I need to do tangent ray B, CB here, and then I got chord BD, And if I got a tangent that meets a B with another chord, I'm going to know that's going to be 1/2 the intercepted arc's measurement, right? It's for the measurement of that angle. Okay, so formula. When I'm on the circle, the vertex that is, when the vertex is on the circle, here's my formula. Measure of angle CBD equals 1/2 the measure of its intercepted arc. So if I see C here, I see D here, that's going to give me where the arc is. And this should have put another point there to emphasize that this is a major arc. So maybe I'll put point Z right here. 1/2 measure of arc. Let's see, put point Z here. This is definitely a major arc right here. This is actually it's just a minor arc here, but measure of arc. I don't even need the parentheses there, do I? I don't need the parentheses there. Measure of arc, what? CZD, okay, right, with Z kind of in between C and D here. But anyways, in the interior of the angle. So anyways, the key thing is when we're on, okay, when we're on vertex, that's it. Vertex the angle on the circle, right? We're going to be 1/2 the measure of its intercepted arc here. All right, simple enough. Hopefully you're not falling asleep. You're like, I already knew this. We did this one. We've done this one so far, so now let's look outside the circle. Okay, this one came up. This is one we're just like, whoa, how many of these are going to be? Guys, we're done with this. We're done with angle relationships after today, after this weekend when you do your homework. So 3 situations. They're kind of scary, right? They're a little scary if you look at this homework. Ooh. There aren't too many of these. There's only this angle here. Angle 7 looks like in this diagram that came up on the classwork today, because this is a fun problem. I couldn't have skipped that one. This is too much fun. This is so much fun. Anyways, if the vertex of the circle is outside the circle, you have 3 situations. You have a 2 secant angle. So maybe I'll get a point outside the circle and I'll do boom, or spying the circle from there. What do I have? I have 2 intercepted arcs. Check it out. My vertex is outside the circle. I draw towards the circle. That angle is going to intercept 2 arcs. I got this arc here and this arc here. I might do different colors for this, okay? Different colors for this. The one that's closer to the point is always going to be the smaller of the 2 arcs. That'll be true for any of these types here. So, and you'll see that in a second. So we got here 2 secant angles. It intercepts 2 arcs here. 2 tangent angles. But the key thing is vertex outside the circle, okay? Vertex outside the circle. So right outside here, okay? And now I have 2 tangents angle. I do 2 tangents angle. So any point outside of a circle, you're going to be able to draw 2 tangent segments. So that's what I'll do here. And I'll just have to eyeball it. Looks like we're probably tangent around there. Maybe right here. Okay, and then eyeball it here. Remember, tangent segments from a point to a circle are congruent. So these look like about the same length. I think that's acceptable right here. How many arcs does it intercept? It actually intercepts 2 arcs here. It actually intercepts, those arcs summed together equal to 360. Because the first arc here is just between these 2 points, this way on the circle. The other arc here, between these 2 points, this arc, right? Between this way on the circle here. So I'm going to you're actually, the first arc you hit is the closer one. That's important because this is the one you're outside the circle. You got to remember, this is the one that deals with subtraction. Okay, this one deals with subtraction. So this one here, when you're outside the circle, you're not averaging the measures of the intercepted arcs. That's for the one that has the vertical angles here. We'll get to that in a second. Don't you wait here. So that means you're not going to average when you have outside the circle because this arc's so small and this one's a lot bigger, right? That kind of thing here. And that's predictable. So we're always going to take the larger one and subtract the smaller one from it. But what can't you forget? Dividing by 2 as well. So it's kind of pretty close to this one here, just with some subtraction. Anyways, try to get there. Part of math, part of what you're doing here is getting some rules. How do I become organized about it? How do I apply them? This is really it. Organize them. Set yourself up a graphic organizer. Take great notes. Commit yourselves. 4 things. Focus on simplicity when you can. That's what the point of this video is here. So I have a vertex. It is outside the circle. Okay, it's going to follow the same formula. Hey, let's put the formula in right now before I even do tangent secant angles, because you might be like, what? Well, why did I just do that? What I care about is the formula here. Let's add some letters here. I got A, I'll put B here, I'll put C here, I'll put D, I'll put E. Okay, here I'll put A again, I'll do B, I'll do C. And here we actually don't have any other letters I need to put in. So maybe I can put here X, x right here. So we have that. But really the key idea is here, and maybe actually I'll do it a different way. So you leave the letters on there if you want. I'm actually not going to use them here. Here's what I'm going to do. I'm going to call this arc2. Okay, arc2. And I'm going to call the first arc that from the vertex with the angle being drawn here, I'm going to call the first arc that gets intercepted from the vertex again, of course. I'm going to call it arc1. Okay, arc1. So I'm just going to use actually a word for arc here when I express this in the formula. Is it mathematically accepted to write the formula this way? Not really, but I think it makes sense to people, and it's just easier to put aside here. So this is arc1 because it's the first arc intercepted from the vertex of that angle that's outside the arc. And then I have here arc2, which is not technically the second. I mean, they're intercepted at the same time, but it's just like this arc is closer to the vertex. Maybe we think about it that way. So anyways, we know arc1 plus arc2 actually equals 360, but we don't know what arc2 minus arc1 equals. Like arc2 is pretty freaking big in this one, but you could picture it like if this point was closer here, maybe the tangent, no, point was further away. Yeah, the tangents would be a little bit out further. But anyways, so we're going to follow the same formula. So let's get the formula written down here. I know that's the big thing about this, and I didn't want to take too much of your time because you do have a lesson problem set this weekend. So measure of, let's just say angle. Okay, let's put. I can put angle A just for like a generic thing. But the key thing is that point A is outside. Right? Point A is outside the circle itself, okay? This is outside. If A is outside here, point A is outside, my calculation that I would make to find out the measurement of angle A, if I knew what these arcs were, if I knew what arc BC was and arc DE measured, arc BC and arc BXC, if I knew what they measured, what I would simply do is take 1/2. You got to remember the 1/2 thing. The only time the 1/2 doesn't come up is the central angle, right? Because the central angle just defines what the measure of the arc is here. So I got 1/2 and then times by the difference between the intercepted arcs. And of course, I'm going to subtract big from small. So I'm going to do the measure of arc, and I'll do it here for our notes here. I just did 3 letters, arc, whatever, arc right there. These are points here. Maybe I'll do lowercase. I think that's what I do in the thing later. Arc, okay, measure of the arc. Okay, measure of the arc2 minus measure of the arc1. Okay, so hopefully this doesn't overwhelm you too much, and you can read, react, and apply something like this on problems like this right here or this right here. So this one, easy enough. This is an easy problem. What's the measure of angle 6? I think that might be on the homework this weekend. Yeah. Or it was on the classroom exercises today. Yesterday. I'm not sure. Measure of angle 6 is going to be 160 minus, well, not 120. So what does this have to be? So this whole thing's 360. Take away 160, that would be 200. 200 minus 120. So there's an 80-degree intercepted arc here. So this one here this is actually a situation we haven't talked about yet. This will be the third one we draw in. But anyways, this one would be, because my vertex is outside the circle, it's the arc that's intercepted kind of second, right? Because this side of the angle intercepts it. This after it gets that arc right here. 160 minus 60 is 100 divided by 2. 50 degrees right there. Okay, 50 degrees right there. Did I do that right? Let's see. 200, never mind, I was wrong there. This is 160, so it'd be 200 degrees left would be this arc, so this would be 80 degrees right here, my bad. 160 minus 80 is 80, divided by 2, 40 degrees. That makes a little bit more sense. This doesn't look like a 50-degree angle. It looks like less than a 45-degree angle for sure. So 40 degrees for angle 6. Simply subtract and divide by 2. That's it. Right? That's it here. Stuff's complicated up front, right? You get those lessons here. There's just a lot to kind of break you in on, to give you logic around. But ultimately, we want to get to what do I know? It's really these formulas and use them here. But you want to know the beauty beyond that. That's why I filmed those are wonderful long lessons. Okay, I need to move on because my goal is to do this in like 15 minutes. So I'm belaboring this. All right. Tangent, secant, angle. That's this situation right here. Maybe I'll just draw it in real quick here. But the key thing is point is outside the circle. That's how I can plot. So there's my secant right there. And if I have a tangent, tangents from here is going to be like maybe like here. There we go. Okay. Oh, that was messy. Now I'm wasting your time here. Come on. There we go. Tangent right here. Okay, so my arc2 is this guy. Okay, to the point of tangency, right? We can end there. This is arc2. and this is arc 1. This is just a neat relationship, right? That's the whole goal, is to study circles for like 3 weeks and find some neat relationships here. Might get bored to death a little bit here and there, but it is what it is. You can use it to solve some problems actually pretty quickly once you get to the bottom of things here. All right, we need to wrap up here. Okay, center of the circle equals the measure of its intercepted arc. If my vertex is on the circle, it's going to be 1/2 the measure of its intercepted arc. If my vertex is outside the circle, then my measure of my angle, whose vertex is outside the circle, would be equal to 1/2 the difference, arc 2 minus arc 1, right? 1/2 of that, right? Do the subtraction first, divide by 2, you're good to go. What about if it's inside the circle? Well, I think you know that one. There's only one type here. It's called a 2 chords angle. And technically, this actually would be true for the central angle too, right? We can maybe talk about that for a second if you wanted to, but also Mr. Fortin's belaboring, so maybe not. Okay, inside the circle, so let me draw in 2 chords. This is how it works. My vertex is inside the circle, and that means I got 2 chords that are intersecting, right? And my vertex here, inside, okay, inside. So we've talked about center, on the circle, outside the circle, and finally vertex inside the circle. Okay, vertex inside the circle. So if I want to figure out, this is a little bit hard here. You got to talk about which angle you're talking about. I'm going to mark up this as my angle of interest here, angle 1. Okay, and the way I keep this in mind, the way I try to remind you guys of here is, what do you think the 2 arcs are that are related to angle 1? What's going to kind of give you that out here is, if I could ask you here, what do we know that angle 1 is congruent to? What's the other angle that angle 1 is congruent to? Well, all vertical angles are congruent. So we know that that angle is congruent to that angle. So whatever formula we use for determining what the measure of angle 1 is, it also needs to work for the measure of its vertical angle, because vertical angles are congruent. So whatever formula we're using, it's got to be exactly the same. So then the question is, well, what are the 2 arcs related to these 2 vertical angles? And I think you got it here. I'm going to move on so we can get on with our merry lives here. Here's my arc 1. Okay, here's my arc 2, where it would be the intercepted arc of its vertical angle. And what do? We simply average those together. And beautiful, right? Gorgeous. The beauty of math is it just fits together right now. Those 2 things converge somewhere inside the circle. This angle and its vertical angle will share the same measurement, and that measurement will be the average of the 2 intercepted arcs between the vertical angle and the angle itself that you're interested in getting the measure of here. So I got measure of angle 1, and that's simply going to equal, well, let's average them. So what do you do to average 2 numbers? Well, you take half of their sum. 1/2 times by arc. Doesn't even matter if arc 2 or arc 1 first. I'll just do arc 2. I should have done the measure thing. So measure of arc 2 plus measure of arc 1. And there we have it. We have our final formula right there. Okay? You can apply this in the problem set that we have here. Check it out. This is 75 degrees. This 75 degrees needs to be the average of 100 and x here. Okay? So 75 is the arithmetic mean, right? The average mean. We've done arithmetic means in a while, but it's going to be 100 plus x divided by 2 equals 75, okay? So what plus 100 divided by 2 would equal 75? Well, 150 divided by 75 divided by 2 would be 75. So that means x has to be 50. We're good to go, right? Scary diagrams at first, but I think you'll be fine on this problem set. I think you got this here. You had to do that one. Actually, you did that one for classroom exercises on Thursday, so hopefully you got it okay. All right, we did it. Center of circle, on the circle, outside the circle, inside the circle. Inside circle's not too bad, right? It actually works for the central angle, actually, as well, because remember, a central angle here, I went back to the first one here. That formula for inside the circle, you notice here, I didn't say that's not necessarily the center, because it actually works for the center, because a central angle, like if I extended this here, okay, my vertical angle over here would intercept an arc of the same measurement. So anyways, yes, it would actually work. The 2 chords angles theorem does technically work for central angles too. It just would be a more complicated calculation. There's no reason to add them together and divide by 2. Just take the measure of one of them. these arcs would be the same. Okay. Anyways, I went over that quickly. Here's your summary. They're here. Hopefully this makes a little more sense, and hopefully you have a little more trouble, a little less trouble remembering them and knowing what to apply them and pull up at the right time here. Okay. Got about another week and a half or so of chapter 7. We'll quiz you. I'm thinking quiz will probably be not this upcoming Wednesday, the Wednesday after. And then after that, we'll look at area and volume. We'll probably not review anything at the end of the year. We'll just look at area and volume. Probably not have a quiz on that too. So last quiz I think is coming up potentially next Wednesday. All right, message me if you have any questions. Thank you for watching. Hopefully this helped. Have a good rest of your weekend.